Alright, in this video we're going to be talking about Big Idea 5, which is basically uh, energy of a system is conserved, and what we're going to be focusing on is Kirchhoff's loop rule. Now, Kirchhoff's loop rule is basically the sum of all voltages, the sum of all voltages slash voltage difference is equal to 0. So basically, what it's saying is it's applying the law of conservation of energy, well, of electricity, electric charge in a Big Idea 1, and the only thing to do is to just prove that it's really true. So I'm going to draw a circuit, big, small, wait, hold on. So let's say you have a big battery over here. Say the voltage of this is, I'm going to say the voltage of B, which is voltage of battery, is equal to, say, 100. 1, 0, 0, V. Draw the current. First resistor, straight line, second resistor, straight line, go up, go up, regular resistor right here, wait, resistor right there, and then come back down to this battery. Alright, and let's say we have a current that's going in a clockwise direction of 4 amps. 4A. There we go. Equals current. 4 amps. So this is going to be, we're in a clockwise direction. You always start with the battery, and let's say we make this the first resistor, so R1, and we make it like 10 ohms. 10 ohms. So R1, go down, this will be R2, and let's make that, let's say 8 ohms, and R3, which is a question mark. And this is what we're trying to figure out. This is how you prove Kirchhoff's law. So basically, it's saying that the sum of all the charges is going to be 0. Well, the sum of the voltage difference. So if we wanted to expand our equation from earlier, it's going to look like this. Sum difference of voltage. So you're going to have the voltage of the battery minus the current I times the first resistor R1 minus the current times resistor 2 minus the current in resistor 3. Current times resistor 3, and that should equal 0. So if we wanted to expand that, we would have, okay, new file. So to expand that earlier one, we would have voltage of the battery, which was 100 volts. So 100 minus the current, which was 4. I'm just gonna label current was equal to 4. R1 was equal to 10. R2 is equal to 8, and R3 is unknown. So we're gonna get 100 minus the current, 4 times 10, so 4 and 10, minus the current and R2, which is 8. Minus the current and R3. is equal to 0. So if we just simplify this, we get 100 minus 40 minus 32 minus 4 R3 equal to 0. You simplify it even more, you get 28 volts minus 4 amps times R3 equal to 0. And now we can just rearrange the formula by dividing. Oops. Hold on. Okay. And we can just rearrange the formula by making. We can rearrange the formula by making negative 4R3 is equal to negative 28 volts. Oh, hold up. There we go. Divide negative 4. Well, divide by negative 1 on both sides. And you should get give me a second. Negative 4R3 is equal to negative 28 volts. Divide by negative 1, divide by negative 1, you get 4R3 is equal to 28. And you just isolate R3 divided by 4 on both sides, and you get R3 is equal to 7.00 ohms. And that's about it for Kirchhoff's law and what you need to know for Big Idea 5b.